Welcome. If you have ever wanted to learn to code but felt intimidated by the complexity, today is your day. Kotlin is a modern programming language designed to be clear, concise, safe. An excellent starting point for new programmers and a powerful tool for experienced developers. Language of choice for apps on billions of devices, especially in the Android ecosystem. We're going to demystify programming by building a small, interactive application, step by step. You will not just watch, you will write the code right along with me. By the end, you'll have a working program and a solid foundation in Kotlin fundamentals. So, what exactly is this language we're about to learn? Kotlin is a statically typed programming language that runs on the Java Virtual Machine, or JVM. Now, that might sound complicated, but what it really means is that Kotlin was built to be a modern, improved version of Java. Java is one of the most widely used programming languages in the world. Because it runs on the JVM, it has the incredible advantage of being fully interoperable with Java. This means a Kotlin program can seamlessly use the vast universe of existing Java libraries frameworks that have been built over decades. Think of it as being able to speak a new, more expressive language while still understanding and using an older, very established one. But why should you, a beginner, care about this? The primary reason is that Kotlin was designed with the programmer's happiness and productivity in mind. It introduces features that help eliminate common sources of errors found in other languages. One of the most significant is its approach to null values, the concept of nothingness that notoriously causes programs to crash. Kotlin's type system is designed from the ground up to help you avoid these null pointer exceptions, making your code safer and more reliable. This focus on safety means you spend less time debugging frustrating crashes and more time building features and bringing your ideas to life. Before we can write our first line of code, we need a place to write it and run it. This is called our development environment. The good news is that getting started with Kotlin is incredibly easy, and you do not need to install any complex software to follow along with this lesson. One of the best ways to begin is by using an online Kotlin editor. These are websites that provide you with a text editor and the ability to compile and run your Kotlin code directly in your web browser. A popular and official option is the Kotlin Playground, which you can find by searching for Kotlin Playground online. This is the simplest path. Just open the website and you are ready to go. For those who plan to continue their programming journey beyond this lesson, it might be worthwhile to set up a professional development environment. The industry standard for Kotlin and Java development is IntelliJ IDEA. There is a free version called the Community Edition, which is more than sufficient for our needs. Every Kotlin application, from the smallest script to the largest enterprise system, has one thing in common: an entry point. This is the designated starting line where the program execution begins. In Kotlin, this entry point is a special function called main. A function is a named block of code that performs a specific task. Think of it as a recipe. The main function is the master recipe that the Kotlin runtime system looks for and executes first. Everything else in our program will be initiated from within this main function. Let's type the following into your editor. Do not worry about understanding every part just yet. We will break it down immediately after. It is important to type it exactly as shown, paying attention to the parentheses and the curly braces. Kotlin fun main. Let's dissect this simple structure. The first word, fun, is a Kotlin keyword that signals the beginning of a function definition. It's short for function. The word main is the specific name we give to this function. This name is special. It tells the system that this is where the program starts. Following the name are a pair of parentheses. Finally, we have a pair of curly braces. A program becomes much more interesting when it can interact with a user. Let's make our program do that by first asking the user for their name. To display a message on the screen, we can use the print function. Inside the main function, s curly braces, add this line. This prompt will not move to a new line, so the user types right next to it. Kotlin print, enter your name. Now we need to read their response and store it. This is where variables come in. A variable is like a labeled box for information. Create a variable named name to hold the text the user types. Kotlin val name jas readline. Readline reads a line from user input. Val declares a read-only variable. Kotlin emphasizes null-safety. Readline might return null, and Kotlin forces handling that. Make the variable nullable. Val name string cheers readline. Use the Elvis operator to provide a default. Val safe name cheer name friend. Now safe name always contains a string. It will be either the name the user entered or the word friend. Greet the user using println. Println adds a new line at the end. Our program can now greet the user, which is a great start. Let's add another layer of interaction by asking the user for a number and then performing a calculation with it. Just like before, we will start by prompting the user. We will use print to display our request on the screen. This tells the user what we expect them to do next. Add this line to your main function after the greeting. Print, enter a number. The user will type a number, but when we read it using readline, it will be captured as a string of text, not as a numerical value we can do math with. So, our first step is to read the input as text. We will then need to convert this text into an integer. Kotlin provides a safe way to do this with the toIntor null and function, which attempts the conversion and returns null if the text is not a valid number, like hello. This prevents our program from crashing. Let's add these lines. Val numstring, botch readline. Val n botch numstring, to intor null. Now, we have a variable n that is either an integer or null. We need to handle both cases. What if the user entered text instead of a number, or a number that isn't useful for our calculation, like 0 or a negative number? We can use an if statement to check for these conditions. If n chow null n chow print ln, please enter a positive whole number. Return. As programs grow, it is a good practice to organize code into reusable blocks. We have already seen one type of block, the main function. Now, let us create our own custom function to make our code cleaner. We can take the logic for calculating the sum and move it into its own dedicated function. This makes our main function easier to read and allows us to reuse the summation logic elsewhere if needed. Let's define a function called SumUp2 outside of our main function. It will take one integer as input, which we'll call x, and will return an integer result. Fun SumUp2x int. Int, return x plus 1, 2. This function uses a simple mathematical formula to calculate the sum, which is much more efficient than a loop for large numbers. The fun SumUp2x int part defines the function sname and its input parameter x of type int. The int after the parentheses declares that this function will return an integer value. The return keyword specifies the value to be sent back. Now, back inside our main function, we can replace the loop calculation by simply calling our new function and storing its result in a variable. Val result, SumUp2 in, println. Result from function is result. Let's take organization one step further and introduce another fundamental concept in modern programming. The class. A class is a blueprint for creating objects. An object bundles data properties, functions, methods, class person, val name, string, fun greet, println, hello from name the Kotlin learner. We have now explored all the individual pieces of our application, getting user input using variables, making decisions with if statements, looping organizing code with functions and classes. Let's put it all together to see the complete final program. This is the code that you should have in your editor, from top to bottom. Fun main, print, enter your name, val name, string, pyakra readline, val safe name, shaker name, friend print ellen, hello, safe name, print, enter a number, val numstring, read line, val and xiao mix numstring to int or null, if n xiao non null, now on n 0, println please enter a positive whole number, return, now val result, now sum up to n, println sum from 1 to del n is result, val p, now person safe name, p dot greet, fun sum up to x int, return x plus 1, 2, class person, val name, string, fun greet, println hello from Chiao's name the Kotlin learner, meows. Let's take a moment to look back at what we have accomplished. In a very short amount of time, you have written a complete interactive program in Kotlin. You started with the fundamental entry point, the main function. You learned to print messages to the console. You learned to read user input with readline. You learned about variables using val. You learned about null safety with the and operators to prevent crashes. We then moved on to controlling program flow. You used an if statement to make decisions. You validated user input to ensure a valid number before proceeding. You performed a calculation. You refactored that calculation into a sum up to function. You got a glimpse of object-oriented programming by defining a person class. You created an instance of that class. These are the essential building blocks of most programs. This has been a quick but dense tour. The most important thing now is practice. Programming is like learning an instrument. True mastery comes from repetition and application. As a small challenge, modify the app we built. Ask for 2 numbers. Create functions for sum and product. This will give you direct practice with everything we've covered.